any country to be self-dependent on what they need. But there is a time and there is a phasing. So not everything is make in India today. Some of them make sense today and some over time will gradually get there. What is needed for make in India is not a factory. That's the last thing that we can do in medtech at least. I don't know other industries. Pharmaceutical is very different. We need an ecosystem. If we are making a knee prosthesis, there is a deep knowledge about everything, metallurgy, shape, machining, design, different parts of the knee system. It is very, very precise. We cannot even go wrong by 0.001. That is far ways away from make in India. If we start thinking about heavy equipment like a bed, like an OT table, where designs are there and we start with assembly first and then gradually ancillarize and start making in India, that is the path probably, because medical device, Stryker itself has more than 60,000 products. Actually, we stopped counting after 2015. This is a area where everything is separate.
So is Stryker doing something about make in India or not as yet?
So I'll give you an example. We haven't yet done make in India, but we have done design in India. Our engineers and our frugal mindset is very, very important in design concept. So I'll give you the example of a power tool which is used by an orthopedic surgeon to make holes in the bone or to slice the bone for doing surgeries. We have a power tool which is called the Mercedes. You talk to any orthopedic surgeon, you say Stryker, the first thing is power tool. We make the best. We invented the power tool, so to say, in the industry. Now the one that we import from the US and we try to sell here, it is fantastic, but it's very expensive. We gave it to our engineers in our R&D center in Gurgaon and I said, we want the cost squeezed out of this, do frugal engineering. Two things I'm going to give an example and tell you what Indian mindset can do. Something like you said, somebody divides the tab and we use it. They looked at Stryker's power tool and they said, sir, the big cost driver is the electronics, which is put in the tool, and every time a surgery is done, you have to sterilize. So you sterilize, you think of boiling electronic items, the cost goes up because those electronics are very, very expensive. So first design idea, what if we don't have to boil the electronics every time? Very simple. Design a module where the electronics goes in, you do the surgery, take it out, only sterilize the metal casing. Electronic cost come down by 80%. Second, Stryker was a very, very precise engineering firm. Everything tolerance at a level which doesn't have a clinical relevance. So we did a study of the tool and said, which are the pieces where you need high tolerance? Which are the pieces where the surgeon or the patient would not have any impact? So today, Stryker in the US machines the tool. We take a block of metal, machine it fully, and then make the tool. In India, we cast it. So the cost of casing went down 80% again. So we launched this tool last year in India, but we don't make it in India. We are not yet there with the ecosystem. We took the design to our factory, Stryker's factory in China, manufactured and brought it here. In 6 months, we sold 100. On an average, we've been selling.
How much was the price differential?
So it is down by about 50% from what we sell as our Mercedes. This is 50% down. It does exactly the same job, by the way.
Great. Good. So probably, look at some other things, beds for example, and knock it down by 50%. I think, most of us will buy probably Stryker beds.
So we have done that, Vivek. Our beds are also similar. They were designed in India.
Okay.
But they are manufactured in Turkey and brought back. Like I said, we need an ecosystem. I cannot manufacture a medical device in a system that I am not confident about delivering 100%. Like you said, sir, in healthcare, 0.1% is also not acceptable. So we make a bed and our bed has an alarm system. If your patient goes out, it will blow an alarm. We weigh the patient in the bed. So for an oncology patient, you can calculate precisely how many milligram per kg without having to get the patient up. So we have every device which is intelligent, but it requires a lot of care. So make in India will happen, but not today.
Okay. Jayesh, coming back to you, you have seen hospitals evolve, and mostly now corporate hospitals also probably are becoming cost conscious, because I think people have realized that, making a 7-star hospital probably costs you too much. I don't know. I'm just, making a guess. And whilst doing that, are you still, looking at patient centricity as the key driver for designing hospitals? Anything from us?
Yeah, that's the basics. That's the important part which we have to look at in terms of architects. So, yeah, we might create a 7-star or a 5-star or an expensive lounge or a visitor area. Like recently, we are doing an onco block, a couple of Linacs in one of our projects in Delhi. But it is actually accessed through an escalator and a lift which opens two sides, which is like a glass lift, which you normally see in the airports. But the idea is that the patient and onco patient, he gets his own dedicated entrance right from the car park, without getting into any other circulation or an OPD circulation. You enter in through, you go through the lift, you go down a bunker which is usually earlier supposed to be dungy, but now we are going through all this Italian floor. There are fountains which are there on the right hand side. It's a water body which is there. There is a submerged courtyard which has been provided, in which allows a lot of natural light. There is actually a retail counter there for the attendants or anyone else to even buy some cafe or something like that. And then the waiting area is actually naturally lit and overlooking a garden area. So this kind of an experience we are trying to give, and the overall experience, if the satisfaction level of this patient, who's an onco patient, he's going to so many other places and so many other hospitals, this is actually standing out. And soon it will be commissioned in a month, but this is what the aspect, like one of the aspects we are taking into consideration.
So anything from your side as to how hospitals are evolving? I think one of the very clear-cut thing which is happening is it is becoming more patient-friendly and patient-attendant-friendly.
Yes.
I mean the amount of facilities that you see. So anything?
Two things which we have done, even in the IGBC rating, if you see, 37% share has gone into infection control, and we call it indoor environment control or quality, in which indoor air quality, this patient-centric in the form of taking the nature as a part of it, and also what we have taken note of is the other infection parameter. And the important part today, nature is a great healer. It has been well understood. People are going back, and we are definitely taking note of that. It is the actually crux in the green building rating system.
Okay. So before I open it for audience again, just one quick one. Do you have anything you think Stryker would like to share in terms of what Dr. Chandrasekhar shared with us? Is there anything which you think would come to India in terms of a Stryker product or something which is futuristic?
Yes, actually I have a video. If we would play the video, it's called True Rise, and as it plays, I'll tell you how Stryker thinks about. Vivek has been talking about patient centricity. Patients recovering from surgery, it is well proven through clinical trials that early mobility provides a unique benefit of patient's recovery. But mobilizing a patient early is a tough task. And this has been a challenge for many years. And Stryker came up with a device which is called True Rise. It's a very simple device, and it's difficult for me to describe it. I'll help you see it in the next couple of minutes.
Its importance to a patient's health and well-being cannot be emphasized enough.
So this is what like? Is it a chair, a bed, or what is it?
It's neither a chair nor a bed, but it looks like both. If you travel in airlines and if you are in a lie flat seat in an airline, it probably resembles that. It suits the needs of many different types of patients.
It is to be used in which area?
It is to be used for patient recovery. So as soon as a patient is out of surgery and you want the patient to be independent and become mobilized.
Okay.
Right, so how do you do that? In India, you will get 3 people to lift the patient up, make them sit down, make them walk. But many times there are issues of patient falls.
Yeah.
You have to train the nurse how to get the patient up. So this device actually frees it up, where you can let the patient choose. You can only send the nurse at 9:30. At that time the patient is sleeping. Here the patient can choose that they want to wake up at 11 and be mobilized at that time. So you give control of mobilization in the hands of the patient, and you reduce the fall of the risk, and you enable the patient to be mobile, which has a psychological as well as a physical impact on the recovery. So Vivek, is it taking time for us to find the video?
So what I will do is, till they fix it up, we will seek questions from the audience. So yes, I think I owe it to her. You'll need a mic, ma'am.
I'm neither a doctor nor an architect, but I'm a textile technologist, and I'm quite keen with the wearable technology and technical textiles to be used in medical field. So what I was looking at your presentation when you spoke about having 24/7 monitoring of using sensor technology for even post-recovery, seeing that, how you can actually take even a regular person, get monitored with the vital signs, give the feedback to the doctors. These kind of things are seen a lot with many such companies which are doing, like maybe AIQ or maybe Hedeco and things like that. But then what happens to India? I mean, how do you see the Indian market taking it? Why is the Indian market not really accepting such products which are so very next to your body? I mean, what's the reason to it?
I'll not say it is not accepting. Only thing is, the speed is not that fast. See, why did I show you all this? Lot of people, because see, why I brought these things and showed it to you is, I travel all over the world. So I could at least sensitize our people that this is needed. And once that is done, lot of people are interested in coming in. Then what I tell them, my dear, you bring a technology which works on 2 Mbps line also, because I have a network issues also. This problem I posed it to Planning Commission at that time, that in the 12th plan, make sure, because I shared this experience when I was just traveling in Uttarkashi, I am talking on telephone, suddenly the driver stops and I told him carry on, he said okay, because he stopped, because he said after that you will not get network. So I said, if these technology is very good to see it in conference, and if you want to really see that, my network should be good. So that has been taken as a challenge, and in this 12th plan, each even up to primary health center they are providing. You must have noted that the only difference is there are some state which are much faster and some state. Right now, if you want to see these kind of a technology, go to Karnataka, go to Andhra Pradesh or even Tamil Nadu, even Gujarat, you will find it. But it takes time.
I think it's up to us to embrace the technology,
Absolutely.
Again, going by doctors, think how many of us have Samsung or iPhone? Please raise your hands. You see? So that's how it just changed. Okay? So about 3 years ago, you wouldn't have dreamt about it, owning a phone at 50,000 rupees. Why you're doing it? Because technology is helping you to do many things. You don't need, I don't carry a laptop now at all. Okay? So that's the thing. So, question? So many questions. We'll go to the lady, sir. थोड़ा जल्दी करो तो एक और ले लेंगे टीपी संघ सर अभी
Tell your name also.
I'm Sarita Rai. I'm from Guwahati. I'm doing my postgraduate diploma in hospital management. Sir, I was doing training for my hospital management in GNRC, Guwahati Neurological Research Center. It is a very old hospital. So there is very good doctors and the staffs are very good. But the problem is it is a very old hospital. They have the setup like that. Like emergency department is very small. Like before it was able to work with 5-6 beds. The radiology department doesn't have that much space. But now if they want to upgrade that, means they want new machines or they want to...
So can I just interrupt you because his video, I don't know, again it will go bad.
Stryker has created a powered
Carry on,
clinical
sir.
chair that not only acknowledges
So,
the value
the video
of early
describes it,
patient
but you can see that
mobility,
it can go in different
it's created
positions.
a new way of mobilizing
Now that you see
patients.
it, you can realize it's
From the
very
external
obvious
design
that
to
something
the
like this should have
functionality
existed
of
for
its
years.
features. True Rise was designed with patient
There is no
safety and
categorization,
comfort.
it's not a wheelchair, it's not a bed, it's called a clinical chair, and all it does is taken every aspect. If you will see, there are different buttons that can be used externally, so if the patient is not able, you can get a caregiver to provide different settings for the patient. If the patient wants to rise, you will see shortly that the knees of the patients from here get pushed up. Depending on if it's a patient on chemotherapy, it's a renal dialysis patient, it can work on different positions. So most common patients who are on a wheelchair in a hospital, we have thought of that, and this is a trend position which is used in certain situations where, so it has thought through all the different levels that a patient needs to be. So it's
True Rise, they have not launched it, sir. Yeah?
there might be. So Chinese are great at copying. So you see here, this gets pushed up. Similar stuff? Great. So I'll come and visit you. I'll learn from you.
In fact, now when I was interacting, you are right because it's there. What has happened? We have added one more this thing because they had accident also. By wrong pressing button, the patient toppled. So the safety features are also now built in.
There is a brake here, which is a safety feature. Plus, there is a lock function.
No,
to
that's
address
what
that.
I said. No, what he's telling, the things have launched in a hurry.
Right.
So, whereas you are taking time and you are taking note of all that. That's what I wanted to address.
एक last question. I know Dr. TP Singh is staring at me with anger. कितने के पड़ेगी सर ये?
With a smile.
सर ये कितने की पड़ेगी?
So we haven't yet
Priced
figured
it.
out with the GST coming in and customs duty getting disturbed. So I actually frankly don't know. In the US, this retails for about $22,000 to $23,000.
Okay.
So in today's terms, about 65, right? So about 13-14 lakhs in the US, but there'll be import duties and maintenance costs, etc. So around that range.
Okay. All right.
Her question.
So
yeah.
What you
this is the
want?
last-
So that's her. Sir, पीछे वाले बोलेंगे
हाँ
तो.
नहीं, बस एक मिनट. What you wanted that upgradation क्यों नहीं हो रहा?
Sir,
That-
upgradation is the question, and the question is कि जब space कम है, like India is not having that much land and space to और बढ़ाने के लिए, like
I'll
तो
tell you.
उसके लिए
There are a lot of central government program. ट्रॉमा के लिए अलग है, इमरजेंसी के लिए अलग है, मेंटल हेल्थ के लिए अलग है, प्रधानमंत्री स्वास्थ्य सुरक्षा योजना में वी आर डूइंग अपग्रेडिंग. It all depends upon the state to decide which medical college to be picked up. So, it is center gives the funding and state has to choose. Right now we are doing lot of upgradation even in the northeast. Okay, probably next phase में आपका hospital का number आएगा.
All right. So, I think, we've, all of you have done extremely good job. A big round of applause for all of them. Thank you so much.
And thank you so much, Dr. Desai, Mr. Malhotra, and Mr. Dave. Of course, we could not answer one question very precisely. We just raised hands. We did not know that we do skid heat there or not. I think next time, all of us, whenever we go to the hospital, we are going to try that. And next time, there would be a precise answer. Jayesh is going to try even more because he is going to design next time the kind of floors which are required. And I think we have given some food for thought to Mr. Malhotra also. He will also now try to devise something so that the operation is performed on the right leg or not on the other leg. So I think all of us would be thinking after this because we have all got a lot of food for thought. Thank you so much. I now invite Dr. B. Ravi. Dr. B. Ravi is Institute Chair Professor Mechanical Engineering at IIT Bombay. He is going to talk on healthcare innovations by bringing clinicians and engineers together. Dr. Ravi, please.
Thank you, sir.
Very good afternoon. I'm very thankful to Professor Singh, who by hook or crook managed to get me here to start with. What I'm going to show in the next 15-20 minutes is about kind of questions which were raised about can India really innovate, where are we there in the ecosystem, can we build the ecosystem, what are the best practices in that, what is really happening here, do you have some examples and stories of that. So here we go. I happen to head a center called BETIC, which I'll show you in a minute, which is perhaps India's at least one place where doctors and engineers have been able to get together, work together, and actually create some success stories. Now, requirements are very clear. I mean, we need a huge array of medical devices, and what is pity is that 79%, 80% of them are actually imported. What also is clear is that many of these devices are so expensive that they're not affordable to the Indian population. And if you look at our companies, very, very few Indian companies are there which are which can meet the demands. Forget about Indian, about world, there is no chance at all. So why are we not able to do innovation in India at this point of time? Let's take a quick look at what is happening in the West. We have big universities where engineering streams and medical streams are right next to each other. We have centers where these two people can get together. They are throwing very good money at the whole thing. And very important, thank you, Mr. Mohit, we have companies like Stryker, okay, whose budget, whose annual turnover is n number of times of India's entire requirement by value. Okay, one company in USA by value is more than twice India's requirement by value of medical devices. Now that is West, fine. If you even turn to East, this is a university in Taiwan, largest university, and they actually got the thing right, which is bed to bench to business, very important, back to bed. Bed in a hospital, bench of engineering, business to expand and manufacture that, and then back to bed to give it to the patients. And as you have seen, medical devices from beds to implants to devices to diagnostics is such a huge component of healthcare that if you don't do something about it, it's going to be very expensive. Normal people cannot afford that. And they have set up these huge medical parks where there are hundreds of companies manufacturing this. Again, by value, if you notice the numbers, Taiwan's turnover of medical devices is about 1/3 of India's by value. And Taiwan is just half of Kerala by size. Okay, if they can do it, why are we not able to do that? So here is one challenge as well as opportunity. One thing is many of these devices made in the West and even in the East, Korea, Taiwan, like that, they're not affordable. That's very clear. Sometimes the price is like 5 or 10 times what we can afford. That's not the only thing. Some of these devices also need to be more reliable than what they use in the West, because our devices, our doctors, our patients will push the devices in the environment, is heat or dust or noise or vibration, or using it many more times than what it is intended for. Okay? Even more important is suitability. He mentioned about the implants and so on. We did a study of the knee implants in India. Our knee joints have a different shape, different aspect ratio of what's called as AP and ML. Okay? The two cross-section areas, the shape is different. So if you take a small size of knee implant made in the West, and put in our patients, it will overhang somewhere and it will be reduced somewhere. So it's not giving the right kind of thing. But they're addressing those kind of things these days. So affordability, reliability, and suitability to Indian conditions is a challenge that gives us an opportunity. On the other side, something magical happened in the last 5-10 years. All these new things, computer design, medical imaging, 3D printing, which everyone is talking about, these are giving us an opportunity to not just leapfrog, but as someone said, to pole vault to the future, literally. Okay? And there's a third thing which is coming in. India medical device rules are coming to kicked in. I mean, they have actually been promoted February last couple of months back. And Jan 2018, they're supposed to be into force. I think Parliament will pass that. After that, no Indian manufacturer can make devices without a certification of device, without a license to manufacture that. And that will make them far more, I would say, scientific and also legal in that sense. So there is an opportunity, there is a threat, but all this put together, it gives us a chance to go ahead. What we need to do is to put the teams together. Because medical device innovation, we have now seen, it is not possible to be done by only clinicians or only engineers. We get to see so many doctors, so many clinicians who in their class 12 couldn't decide. They were slightly inclined towards engineering, but father maybe was a gynecologist. I'm actually talking about a real person. Okay? He said, no, go to medicine. And there are many engineers I have seen who say that, I think my heart is in medicine. And because India has a lot of them, even if it's a 1% of them are like that, it's hundreds and thousands of them. So we need to get them all together. This is my lab in IIT Bombay. It's a shed where it was a costume room for 3 Idiots when it was shot in IIT Bombay. That shed was given to me, and we have set up a beautiful small lab there. And our four goals are this: create a facility where doctors and engineers can talk to each other, use a facility to create a few medical devices, use a thing, go ahead and work with hospitals to actually do clinical trials, because what's the use of that otherwise? And in the process, create a new generation of medical device innovators who can actually perhaps become entrepreneurs and create Indian companies for medical devices. Long shot, but I think we want to start somewhere. If you step inside, we have 4 mini labs. One room which I call as a happy room, the first one on the left, where you have a lot of junk materials arranged very beautifully in all those bins. I2R is idea to reality, paper and plastic and wires and electronics and all camera lenses and all the stuff, which is used for making proof of concept. A doctor comes and says, I want some device like that. We can put together something in 24 hours and show it to him saying, do you have something like this in mind? If he says yes, then you go to the next step, which is the CAD room, where we actually have software to look at human anatomy and design a thing for the shape and size of that. Then we have a room where we can create plastic prototypes. These are high-end 3D printers with biocompatible materials. And we also have set up an electronics room because many devices have a lot of electronics in them these days. Now, this is my team. The top row is faculty, just a few. Actually, I have about 15 faculty members. And then I have 5 or 6 managers and about 5, 6 researchers and about 5, 10 students, about 20, 25 people in my lab. The color coding, if you already understood, green is some bio, clinician or biomedical or biomechanics or biomedical, orange is mechanical or material science, metallurgy, and the blue is electrical, electronics or IT. So I have a fairly good balance, as you can see, reasonable number of dots there. Now, the sweet spot is that we have been very lucky that we have the best and the greatest of the surgeons coming to our lab all the time. These are just few pictures, I have hundreds of them. The top right is Anvay Mole, if you know, is a heart surgeon who has done 50 heart transplants. In fact, many hearts come from Pune and then go to Bombay by helicopter, and then he does that. And it's a 3-hour window. It's a story by itself. Okay. Hemant Bansali, who is a PhD in laparoscopic surgery, has taught hundreds and thousands of laparoscopy surgery to surgeons, and many more like that. The whole bunch is the doctors from Hinduja Hospital. They never came out together to a different place. Okay. And they were interacting for a whole day with them, and so many more like that. But we also go to hospitals. These are just taken a few. I have hundreds of pictures of interactions with doctors and patients and caregivers and hospital administrators in the native clinical environment. And we also go into OT with permission, of course, where we take pictures and videos, because we can always play back in slow motion and study what is right or wrong with that. We have a process for doing that now. Unlike most engineering, and those who engineers in the room, they would know machine design, how we teach and all that. A problem is given and equation is given and you are supposed to solve that. We are teaching people to ask the questions. What is the problem to solve? And the questions can be only started from the clinical immersion. So it starts from a doctor or a clinician. We make a team, go to hospital, study that, define the problem. We don't mind taking 3 to 6 months just to define a one-line statement of what is the problem to be solved. We ask question why many times. Get to the root of the problem. Okay? And then, of course, second part is the engineering stuff where we develop that, prototypes, virtual, real, whatever. The third part, that's where most scientists and engineers stop. We want to push it further. We tell them the big thing is testing the device, testing the idea. And that's not easy. There are no facilities for that in India, not much. Okay? So we make it and do that, preclinical, clinical certification. And then the real fun starts, which is you have to create a business model, file patents, protect your IPR, and then get funding for scaling up. We haven't yet reached the last stage yet, but I'll show you a few examples. What we also found is the ratio is like that. Management people in the room will be very interested to see the ratios. The first step, the second step is 1:4, then 1:3, then 1:2. So your 300 unmet clinical needs which we listed, we could only develop about 10, 12 products. We have a funnel now for taking the whole thing. So we start from a weekend hackathon, just teaching, getting doctors and engineers together, teaching them creativity, problem solving, making a proof of concept. Then you take them into a camp for 1 week, then we take them into a lab for 1 year, fellowship, then you put them in an exhibition, whether we arrange it or in a government or private exhibition, and then we ask them to do a startup. And if that is okay for 2-3 years, then they can have their own scaled up company. This is a hackathon. We did 3 hackathons or camps, and then you can see every team. And the last one, for example, these 4 people. One is an orthopedic surgeon, the guy in the white. So 1 clinician, 1 mechanical, 1 electronics, and 1 industrial designer. Ergonomics industrial designer. This is a very sweet combination we found. It works beautifully. You need the 4 people to repeat one clinician, one mechanical, one industrial designer, and one electrical electronics person. Now we don't do everything under the sky, so we also try to say that we get a lot of ideas. The doctors come to our lab, and we went to the government dental hospital, one visit, 3 hours, we could collect 60 unmet clinical needs. Now we can't do everything, and we should not do everything. So what we do is we look at those where there's a significant local need, number one. Number two, where there's a value proposition. We don't want to make something cheaper by 20%, doesn't make any sense. If you can make it cheaper by 10 times, or make it better by 10 times, it is better treatment, faster treatment, easier, doctor can do more surgeries per day, 5 to 10 times benefit, then it's worth chasing that, because many times 10 times becomes 3 times or 4 times as you go along the way. Then it should be, the team has to be able to do that. We can't make a portable CT machine as of now, okay? And it should be manufacturable, because as Mr. Mohit said, getting tolerances right is not taught in engineering colleges. Okay, we just know design, we just know some basic manufacturing. Real manufacturing is not like that. You talk about how do we get tolerances right, and meeting tolerances, it is a nightmare. And finally, the most important, unless a clinician says, I am with you throughout the journey, all the 4 steps, we don't take it up. We have to get a commitment that he'll meet us or give us 1 hour time every week. Either we meet him in the hospital or he comes to lab and meets us. Without that continuous feedback, we won't take up a project. Okay, so here are some of the examples of what we could do in the last couple of years. These are all surgical instruments. The first one, of course, is software. It takes X-ray, converts into 3-dimensional picture. Believe me, it is possible. It took us 3 years to do an algorithm for that. It's an artificial intelligence algorithm. The top one is a flexible laparoscope, which has additional movement. Most laparoscopes are just straight. It has additional wrist at the end, and I can do very complicated surgeries with that. The middle one in the green is a heart template. You know, heart valves you must have heard about. But this is, you can cut out a portions of a patient's own heart, pericardium, and you can stitch it, and Anvay already has used it, and I'll show you pictures of that. And the fourth one is for nasal ostomy, nose deformity corrections, it's used for that. We have also done about 4 or 5 diagnostic devices. The first one has won already some prizes. It is a digital stethoscope. Take a normal stethoscope, plug our device into that. It can do noise cancellation, it can do sound enhancement, you can play back, record, and we are now putting a Bluetooth. So if you have a similar stethoscope, I press a button and I can hear in your stethoscope. We can look at the value in terms of creating a repository of educational material, or for teaching purpose, or of course for telemedicine, and many more. There's a clubfoot brace sensor, which a Stanford Biodesign could not do it. We picked up the project, we could do that. Diabetic foot sensor, and then a glaucoma scanner, which has already been used to screen patients, and a biopsy gun with Hinduja Hospital, plus 2 devices for rehabilitation. One is a splint and second is legs prosthesis. Because time is short, I'm going to show you just one of these, maybe 2 of these. This girl is from Somaiya College in Bombay. Normal college, I just met her in a conference like that. She said, I want to work with you. Her mother had a heart valve and she had passed away. I didn't know at that point of time, by the way. And she said, you want to work with us. So she worked with Anvay Mule, and she created this, what we call as valve template, using which Dr. Anvay Mule already has done 5 heart surgeries. And all of them are working, thank God, and I'm very proud and a little shaky about it, but I'm very proud about that. So this actual surgery happening with that. The other second story I thought I'll share with you is, we thought the Jaipur foot is 30, 40 years old. It's just same, it's painful, it is cheap of course, but it is very primitive if you look at the whole thing, the way it's designed, manufactured and used. So we thought, why not take a look at the whole thing. This is not Jaipur foot, what you see is a slightly better version. So first thing we said is we'll put a knee joint, so patients can flex their legs. Jaipur foot originally doesn't have a knee joint, it's just a straight one. But if you want to cycle it, you just free the 2 parts and then you can cycle it, but there's no power transmission in that. Second thing we did was we brought in CAD/CAM and 3D printing. So this is India's first 3D printed socket which goes onto the amputee's leg. It fits like a glove. If it fits like a glove, pressure transmission, force transmission is much better. So pain is less. And the 2 knee joints we got one from Guwahati, one from Madras. But as we speak, today morning we inaugurated another conference in Bombay, Navi Mumbai MGM Hospital. I'm coming literally from there. And we have all the people gotten together, the big conference there itself, and we're trying to see how to promote these biomechanics further in the country. And here is a picture of the first patient who got it. He's an electrician from Daman, And we also took him into the gate lab. So we're actually studying the energy and movement and kinematics and dynamics and looking at how this joint is different from a Jaipur foot is different from a normal human gait, and how do we minimize the energy expenditure, which means he can walk more without getting tired. Okay, this video obviously I never thought it will work, so we'll forget about that. Our devices already have touched many patients. Okay, I counted about 125 people we already touched. And remember, we just started 2 years back. 2014 December 15 we started. So in 2 years we were able to develop and touch so many patients. Glaucoma device on the top right which you see, it is a non-invasive. The one which are currently marketed, they have to sit on the cornea, you need a anesthesia there. This sits on the eyelid. Everyone feels comfortable, and we actually benchmarked, it is actually able to screen, and it is actually able to catch glaucoma patients. Okay, and there are many more in the pipeline. These are all devices still in the lab, like Google Labs. All these in the pipeline, many more will come out this year, next year, and so on. And there are many, many more after this also. And some of these devices, like Incline wheelchair, it was done by a bunch of students from Kolhapur, whose college name also you won't find on the website. It's a very simple college, no teachers, no facilities. These kids on their own, just because they heard a lecture from me somewhere, they just got fired up and did that. I mean, I am so thankful and amazed at the passion, energy, and hunger that exists in rural colleges. I sometimes feel IIT students are useless. Okay. Okay. But as he says, we are way off. I think we are 10 years away from. Striker to bhul jao, striker to no chance. So we also create platforms, because where will these people exhibit their device and show to doctors? The first one is a first rural medical device exhibition, happened in Derwan, Chiplun, if you know the place. And we had 300, 400 doctors coming there from all over Kolhapur and other places. Dr. Anil Kakodkar inaugurated this. I'm very thankful to him. The second was done in Pune last year in April in COEP, College of Engineering Pune. And we had about 50 stalls, about 80 innovators exhibiting, 60 innovators, 80 exhibiting about 90 devices. And you can see this girl and this girl, and I was very happy about that. And they talked to each other and had a lot of best practice sharing. That is more beautiful. We also have a model of commercializing. I actually had to fight in IIT to give IPR credit as well as revenue to clinicians. I told them clinicians are a critical part of our whole ecosystem. But IIT system did not allow external people to be named or at least revenue sharing in the whole thing. So I fought with my own IIT. We can give clinician 1/3 share, researcher 1/3 share, and IIT keeps 1/3. I'm okay with that. And then of course manufacturing, I have two routes. I tell my team, if possible, do a startup. After all, you're a mother of the baby, you only bring it up. Okay, that's a startup. And the IIT has its own technology business incubator. People can start companies. They're given space and mentorship and whatever, things like that. And the second route is licensing. If you don't want to do, okay, license to someone else, preferably Indian companies, because it is taxpayers' money and we would like to benefit Indian companies. And again, there are two routes of that. If the manufacturer wants to make a profit, we take some initial fee and royalty. If the manufacturer says, I'll give it free of cost, like a hospital or NGO, and we have examples of that also. We give the licensing also free of cost. Okay, so Betic already, the circle in the middle, already has 5 or 6 centers, sub-centers. There's one sub-center sitting right now in Pune, College of Engineering Pune. The second one is in VNIT in Nagpur. The fourth one, we are going to inaugurate this month or next month in Shivaji University, Kolhapur. Then there are 2 green ones. One is MGM Hospital, where I said today's meeting was there. And second one is BK Valvalkar Hospital in Derwan, Chiplun. Those who have not seen this hospital, it is like for me a wonderland. I don't know how many have heard about Valvalkar Hospital in this room. Wonderful. You agree with me. Okay? They have a sports stadium. I mean, along with the hospital and engineering medical college, which started 2 years back. They have a stadium, and the stadium has Olympic level guns and archeries and Olympic level swimming pool and artificial track. IT doesn't have that with all our money. I mean, I was amazed. They are training rural people to become Olympians, and it will happen in the next 25 years. That is just the side part. I've not talked about the main thing, which is the hospital, which they are given free, after demonetization, they gave free treatment for about 2-3 months. Everything done from charity, no government money, from a single individual, which I don't want to name. Amazing. That's a different story. I don't have time for that either. Okay. Also, we're connecting with all the other people in the country who are doing innovation. I've just mentioned Guwahati, I mentioned Madras to you. AIMS, Jodhpur, you mentioned, and IIT Jodhpur. The two directors came on the stage about a couple of months back. I was there to inaugurate that, and they said, we are so close, 8 kilometers, or maybe something like that. I said, this is a wonderful opportunity. You both should join hands right from beginning and start innovation. So they said, the two directors have at least committed, so I'm very happy about that. But they have to find the actual champions who will run the show. Finally, end of the day, it is all about that. We're also connecting to people across the world. Of course,